Hello and welcome to another video on highest common factor and lowest common multiple. Now in the previous few videos we've looked at calculating the highest common factor and lowest common multiple when we've been given some numbers. In this video we're just going to try and interpret some word-based questions using those skills that we've learnt about previously. So let's just read this question out here. It says a certain number of students can be arranged in groups of either 3, 4, 6 or 8 with no student left behind. What is the minimum number of students possible? So basically we've got a group of students and they can be arranged in either one of these 4 different combinations. So they can either be arranged in groups of 3, groups of 4, groups of 6 or groups of 8. But we know that when they have been arranged, there's no student left behind. So how many students are there? And we're looking for the minimum possible number of students. So in order to solve this, we know that the number of students has to be divisible by 3 because it has to go in a group of 3. It also has to be divisible by 4, it has to be divisible by 6, and it also has to be divisible by 8. So what number is divisible by all 4 of these numbers? Well, we're just going to look at a number that is a multiple of all of these numbers. And it says what is the minimum number of students possible? Well, that's going to be the lowest common multiple. So what we're going to do is we're going to work out the lowest common multiple of these 4 numbers, and that's going to give us our answer. So there are a few methods that we've learnt about for finding the lowest common multiple. One of them was listing, so listing out all of the multiples, and the other one was using prime factorization. So for this particular question, I'm going to use the listing strategy, and I'm going to start with the biggest number. So let's first of all list out first few multiples of 8. And now let's move on to the multiples of 6. And we can see that 24 is a multiple of both of these numbers. So let's keep going. Let's list out the multiples of 4. And finally, the multiples of 3. And if we look close enough, we can see that there is a number that is in all 4 of these lists. And that number is 24. So 24 is a multiple of 8, 6, 4 and 3. And it is the lowest common multiple. There isn't a number smaller than 24. That is in both of these lists. So our answer is 24 students. There are 24 students in this class because they can be arranged in groups of 3. That means there will be 8 in each group. Or they could be arranged in groups of 4, and therefore there would be 6 in each group. They could be arranged in groups of 6, so there would be 4 in each group. Or they could be arranged in groups of 8, in which case there would be 3 in each group. There is no student ever left behind. Okay, so here's another question for you to have a go at. 210 oranges, 252 apples, and 294 pears are packed together in identical cartons, and there's no fruit that is left over. What is the greatest number of cartons that could be used to pack the fruit? So we've got identical cartons. We're going to have a certain number of cartons. They're all the same, and they have to have in total 210 oranges, 252 apples and 294 pears. So what is the greatest number of cartons that we could use to pack the fruit together? So let's just think about this. Let's say we use 10 cartons. So if we've got 210 oranges and we split them up into 10 cartons, then we're going to have 21 oranges in each carton. If we split 252 apples up into 10 cartons, then we're going to have a decimal. 252 divided by 10 is 25.2. We cannot have 25.2 apples in each carton. We can't chop up the fruit. We have to have whole numbers of apples, pears and oranges. So that would not work. So we need to find a number that divides into 210, 252 and 294. Or you could think about it as we need to find a factor of all of these 3 numbers. And because we're working out the greatest number of cartons, we need to work out the highest common factor. So for this particular question, I'm going to use prime factorization to calculate the highest common factor. So if we start off with 210, how can we break down 210? Well, immediately I can see that it's got a 0 on the end, so it's divisible by 10. So it's going to be 21 times 10. And we can break that down even further. 21 is 7 times 3. And 10 can be broken down into 5 times 2. And all of these are prime numbers. So we've broken down 210. Now let's move on to 252. And to begin with, I can see that it's even, so it's going to be 2 times something. So what is 252 divided by 2? Well, I think I can do that in my head. I think that's going to be 126. And if we do the same thing, 126 is even. So it's going to be 2 times 2 times 126 divided by 2. That gives us 63. And now I know that 63 is 9 times 7. So it's going to be 2 times 2 times 9 times 7. And we're not quite done because 9 is not prime. 9 is 3 times 3. So we can break that down even further. So it's going to be 2 times 2 times 3 times 3 times 7. And we are done. So let's move on to 294 now. So 294, and I'm going to use the same technique. It is even, so we can break it down into 2 times something. And 294 divided by 2, that gives us 147. And now you're probably wondering at this stage, is 147 prime? Let's work it out. So it's going to be 2 times, it's clearly not divisible by 2. Is it divisible by 3? So let's do 3's into 147. So 3 does not go into 1. So let's carry the 1 over. 3's into 14 go 4 times with 2 remainder. And 3 goes into 27 exactly 9 times. So yes, it is divisible by 3. It's going to be 3 times 49. And now I can see 49 is definitely not prime. That is 7 times 7. So it's going to be 2 times 3 times 7 times 7. So now we've broken each of these 3 numbers down, we can work out the highest common factor. So what prime numbers are in each of these lists? Well, 2 is in all of these lists. So 2 is a factor of all 3 of the numbers. What else have we got? Well, we've also got a 3. So we've got a 3 here, we've got a 3 here, and we've got a 3 here. So we can say that 2 times 3 is a factor of all of these 3 numbers. Is there anything else? And there's also a 7. There's a 7 here, a 7 here, and a 7 here. So 2 times 3 times 7 is in all 3 of these lists. And I think that's it. Yes, it is. So the highest common factor is 2 times 3 times 7, which is 42. So that is our highest common factor. So to answer the question, what is the greatest number of cartons that could be used to pack the fruit? Well, we could use 42 cartons. We could use 42 cartons to pack the fruit. And if we did use 42 cartons, how much fruit would there be in each carton? Well, if we've got 210 oranges and we've got 42 cartons, we just need to do 210 divided by 42. And I can see, I don't even need to do that, I can see that that would be 5, because that's the only number that I've got left over. So we could say that there are 5 oranges in each carton. How many apples will there be in each carton? Well, we just need to look at what's left over. So it's going to be 2 times 3. So it's going to be 6 apples in each carton. 6 apples. And how many pears? Well, there's going to be 7 pears. There's going to be 7 pears in each carton. Now, the question didn't ask us how many pieces of each type of fruit there were in each carton. But I just thought I'd just do that just to give you a bit of context as to what's going on. So we've got 5 oranges, 6 apples, and 7 pears in each carton. And there are 42 cartons. So hopefully after watching this video, you can not only calculate the highest common factor and lowest common multiple, but you can also apply it to different contexts. So hopefully that was helpful, and see you in the next video. Take care.